guys, Mr. Klein here with our third and final lesson of this chapter on simple machines. We're going to be talking about wheels and axles, screws, and pulleys. So let's go ahead and let's get started. Now, this car, pretty lucky, sliding across. The simple machine I want to talk about, of course, are the wheels and axles, several of which were in the air right there. Without them, we wouldn't have cars or things that move. So let's go ahead and let's dive right into this. But before we get into wheels and axles, let's talk about screws. In the last lesson, you learned about an inclined plane. Remember, that's a surface that goes from a lower elevation to a higher elevation. What happens if you take an inclined plane and wrap it around a cylinder or cone? Well, that's a screw. A screw increases the output of the force by lengthening the distance the input force is applied. So for a screw, you can do one of two things. One, you can go around the center like a staircase where you walk up and you circle around, or you turn the inclined plane itself. And what happens is if you turn the inclined plane itself, it drives in much like a screw. Now, the closer together the threads on a screw are, the less force that needs to be input. But the relationship with force and direction is the less force that you put into it, the longer you have to input the force over a distance. So if you have a whole bunch of threads really, really close on a screw, you have to turn the screw longer because it more rotations for the inclined plane to go around. So for a good example would be this. This is an Archimedes screw used to lift things, kind of like with a staircase. As you can see, the screw itself turns, and as it does, the object is lifted up. So let's go ahead and let's create our graphic organizer for this. We have a whole bunch of spaces we're going to fill out. A screw, of course, is an inclined plane around a cylinder or cone. A good example is a screw. And the change in work is one of two things. You either increase the output force or the output distance, one or the other, and it depends on how the screw is turned. So go ahead and make sure that's written down. And here we go on to the next section. So another simple machine related to another is the relative of the lever. A wheel and axle is actually a lever. It's a circle with a rod in the middle. Okay? If you think of the rod in the middle as being the fulcrum and the wheel turns, that's a lever. Now, the wheel and axle can have the input force done on either the wheel or an axle with different results. If the force is applied to the wheel, the axle turns faster with greater force. A good example of this is a doorknob. If you think of the doorknob itself as a wheel and the inside of the doorknob being an axle, you turn just a little bit of distance or with a little bit of force on the doorknob, and on the inside, the rod turns a whole lot more. The opposite is true if the force is applied to the axle. The wheel turns with less force, but to a greater distance, depending on the size of the wheel. A great example of this is a Ferris wheel. So let's look at an example. Okay, so we're just focusing on the basket on this Ferris wheel. The center of the Ferris wheel is not turning much, the axle. Okay, it's not turning too much. And there's a complicated formula you can use to figure out this distance. But look how much this basket is turning on the outside of the wheel. It doesn't take a lot of force to turn on the inside to turn this on the outside a much further distance. Let's go ahead and let's fill out our graphic organizer now. Wheel and axle is a wheel with a rod in the middle. Good example is a Ferris wheel. And once again, just like a screw, depending on which part you're turning, it's either an increased output force or an output distance is increased. So go ahead and get that filled out. And we're going to go on to the final simple machine right here. That's a pulley. A simple machine related to the wheel and axle is the pulley. A pulley is a simple machine that consists of a grooved wheel with a rope in the groove. A pulley can be used to lift or move an object, and the position of the pulley itself defines this, okay? Whether you're lifting or moving an object. Okay, the simple thing is like, a well. So, you throw the bucket down there, and you could pull, and it requires a lot of work, but with the wheel turning, it makes lifting much easier with the pulley. Now, so like I said, a pulley is a grooved wheel and rope used to lift or move an object, and it changes the output force, distance, or the direction, and it depends on how it's set up, how we're going to look like. There's three types that we're going to discuss here, so go ahead and get that written down. And let's talk about them. There's three main setups. The first off is a single fixed pulley. That's usually what we think of. It's where the pulley is fixed to a structure, like it's fixed on the roof, and the rope is pulled through there. And the object moves with the rope. A good example is a flagpole. If we look at this example right here, unfortunately it doesn't animate, but if you pull down on the rope, the package is going to go up. And as you can see, the pulley, the wheel, is attached to the ceiling, so it's not going to move. That's what we call a fixed pulley. Okay, it doesn't change the force at all, it just changes the direction. So its mechanical advantage is only 1, because for every newton of force you pull down with, it gets lifted up with 1 newton. Now, let's go ahead and fill that out. Fixed pulley with a movable rope, a flagpole, and a change in direction. So here we go on to the next type. Instead of a fixed pulley, we have a single movable pulley. Okay? A movable pulley is where the ends of the rope are attached to ends. The rope doesn't move, but rather the pulley itself moves, increasing the output force. So it moves freely along the rope. A great example of this is a zip line. So if we look at this example here, of someone riding the zip line, as you can see, the 2 ends of the rope are attached and they're pulled really tight. You attach the zip line to the rope, okay, and you let gravity do the rest. You only need a very slight tug, and the entire output force goes, and it rolls on. And because it's at an angle, at an incline, gravity takes care of the downhill pulling by itself, and you increase with a lot of speed. So even if it's straight, you could push, depending on the amount of friction on the wheels, and it could travel a really long way. So that's a movable pulley, a fixed rope attached to the pulley. Zip line's a great example, and the output force is increased. So go ahead and make sure you have that. And we're going to move on to the last part. The last one is when we put them both together, fixed and movable pulleys. So we have a compound pulley. It's a combination of them, and it has multiple pulleys and multiple ropes. Now, depending on the setup, what may happen is the direction may or may not change, but the force always increases. And this gets really complicated because you add ropes and you add pulleys, and it gets complicated with this, like I said. And a great example is a crane. What you can end up with is this example of a crane, lifting a crane, lifting a crane, lifting a crane. And all of this is happening because you have series of pulleys and cables, which ropes, okay, using to lift one, which lifts another one, which lifts another one, which lifts another one. Okay, so let's go ahead and let's finish off this section of our graphic organizer. A compound pulley is 2 or more pulleys linked together, and they can do all sorts of things. It depends on the setup, and the crane is a great example. So those are our simple machines, okay? We have the screw, the wheel and axle, and the pulley. And of course, there's 3 types: the fixed pulley, the movable pulley, and the compound pulley. But what happens when you link them together, okay? Well, what you get is a compound machine, or 2 or more simple machines connected to increase the mechanical advantage. A great example of a compound machine that's relatively simple is something from the last lesson, a wheelbarrow, when you think about it. You have a second-class lever, okay, which you have the fulcrum that pivots, okay, on the end, and what you do is, on that fulcrum where it pivots, you put a wheel and axle. Then what that does, it allows someone to do a lot of stuff with it. You don't just lift the load, but you can also move it. Okay, so it allows you to do things like this, but just don't try this at home. These guys weren't professionals, and it obviously shows. But to talk about the physics involved, okay, the wheel is located at the fulcrum, and so the guy lifting it can lift the guy with not too much force because it pivots on the wheel, and the whole wheelbarrow moves because he, let gravity take care of itself. And in case you didn't notice, there's another simple machine right there. That's the little ramp he jumps off before he tries to injure himself. So anyway, let's go ahead and let's finish off our graphic organizer in this chapter. A compound machine is 2 or more simple machines linked together. Great example is a wheelbarrow, and don't try that at home, kids. And the change in work totally depends on the setup. We can go from something as simple to a wheelbarrow to like an automobile. So there you go. That's your lesson, and that's the chapter on simple machines, work, efficiency, power, mechanical advantage, and all that. I hope you really enjoyed it. Hope you learned something. And if, as always, if you have any questions, please let me know, and thanks for watching.